Organic chemistry is the study of carbon-containing compounds. A hydrocarbon is composed of hydrogen and carbon. If it's saturated, it contains only single bonds between the carbons, while if it's unsaturated, it contains multiple bonds, such as double or triple bonds between the carbons. You need to know the 10 prefixes for naming organic compounds. 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. A saturated hydrocarbon is also known as an alkane. They're going to end in ane. The prefix tells you how many carbons are in the longest chain. To figure out how many hydrogens you have, you can use the formula CxH2x plus 2. So if I have 4 carbons, 4 times 2 is 8, plus 2 is 10. If you have 10 carbons, you should have 22 hydrogens. 10 times 2 plus 2. Go ahead and solve these on your own. Restart when you have it. If you have 5 carbons, you should have 12 hydrogens. If you have 20 carbons, you should have gotten 42. If you're drawing propane, first you need to figure out how many carbons you have. Prop is 3, so you draw your carbon chain of 3. Then just fill in hydrogens. Each carbon can contain 4 bonds because it can only hold 8 electrons. So that one can hold 3 because now it has 4 bonds. The middle one can hold 2, and the end one can hold 3. You also could figure out that 3 times 2 is 6, plus 2 is 8, and so you needed 8 hydrogens, which it does have. You can either draw the hydrogens or you can just draw lines as on the right, and it's understood to be hydrogens. If it's anything but a hydrogen, you do have to put the element it is, though. Pause the iPod and draw hexane. You should draw 6 carbons because hex is 6. And then filling in your hydrogens, you should have had 14 hydrogens arranged like so. Go ahead and pause your video and answer these 2. You should have gotten 12. And on the bottom, if you number those carbons, you have 7, which means it's C-heptane. To name an alkane, they always end in ane. The number of carbons is determined by the longest chain. Carbons not in the longest chain are called substituents and are named by dropping the ane and adding YL. The position of the substituent groups are always specified by numbering the longest chain of carbon atoms starting at the end closest to the substituent. You want the substituent to have the lowest number possible. So looking at this first example, we've got to find our longest chain. If we count across, we have 5. If we count to the left and down, we have 7. And if we count to the right and down, we also have 7. So the longest chain is 7. So it doesn't matter which way we number from the left or right because either way the substituent would have a number 3. That's my longest chain. If it helps, you can circle the longest chain. Everything else is a substituent. First you need to state which carbon your substituent's coming off of. It's coming off of 3, and now we need to say how many carbons. There's 2, so instead of saying ethane, I'm going to say ethyl. And we're changed the ending to YL. And then my longest chain was 7, so it's heptane. So 3-ethyl heptane. Looking at this second one, we need to figure out our longest chain. So pause the video and figure that out and restart when you've got your longest chain. You should have gotten 5 as your longest chain. On carbon 3, we have 1 carbon coming off, which is methyl. And 5 is pent, so 3-methylpentane. If we were going to draw a structure, given the name, the easiest thing is to draw the longest chain first. Nonane tells us we need 9 carbons. Now we're going to start adding our substituents. On carbon 4, we have ethyl coming off, so 2 carbons. Then on the 3rd carbon, we have a methyl group, and on the 5th carbon, we have a methyl group. Now we just need to go and add our hydrogens. Don't forget your hydrogens, or it's not a complete structure. Be careful also that you're only adding 4 bonds to each carbon. If it has 5, that's incorrect. Another way that you can see a molecule is like this. Every point is a carbon atom. So go ahead and pause the video and try to figure this one out on your own. The longest chain is 6, but you have to start numbering from the right, or your substituents aren't going to be numbered the lowest numbers possible. So it should be 2,3-dimethylhexane. A structural isomer contains the same atoms, but one or more bonds are going to differ. If you notice in these two, if you count the longest chain, the top one's longest is 4, and the bottom's longest is 3. So they both have 4 carbons, but they're going to be named different. The top one is butane with the formula C4H10. The bottom one is 2-methylpropane having the formula C4H10. Notice you have the same formula but different names. Those are isomers of each other. They also would have different properties. So go ahead and draw isomers of pentane. Remember to name them so you know that they're a different compound. I'm going to give you the first isomer of pentane, which is simply pentane. Pause the video and draw the other 2 of them and name them. Easiest way is start removing carbons. If I remove 1 carbon, I have 4, and I'm going to add that 5th carbon to the second one, which this is going to be 2-methylbutane. Different name, same formula. If I did that same thing and just moved the carbon to this one, notice it's still 2-methylbutane because I would have to start numbering from the right. So that's not going to work, so now I'm going to go down to 3 carbons. I've got to place my other 2, but notice if I do it this way, my longest chain's still 4, and it's the exact same thing that I just had. So the only place I can put that 5th carbon is at the bottom of the second one. So I get 2,2-dimethylpropane. Dimethyl is in, there's 2 of them. So go ahead and draw the isomers of hexane and give the name of each of those. The first one is simply hexane. The second one, we have a 5-chain carbon with a methyl coming off on 2, so we have 2-methylpentane. We can also make 3-methylpentane. But there's no such thing as 4-methylpentane. Then we can have 2,3-dimethylbutane. And finally, 2,2-dimethylbutane. There's 3 reactions of alkanes that you need to know. The first one is combustion. A hydrocarbon plus oxygen yields carbon dioxide and water. Substitution is when a halogen replaces a hydrogen in an alkane. And I'm going to draw out the structural formula of ethane to make it a little bit clearer. So one of the hydrogens is replaced with chlorine, and so that chlorine and hydrogen go together to make HCl. It could have been bromine, and then it would have been HBr, or any other halogen. And dehydrogenation is when hydrogen atoms are removed to make the alkane unsaturated. So we're going to start with that ethane again. Remove 2 hydrogens to make a double bond, and now we're left with hydrogen gas. A cyclic alkane has the formula CxH2x, so we have twice as many hydrogens as carbons. It forms a ring that's not as stable as the straight alkanes. Cyclohexane is not actually flat or planar. It's going to be in a chair or a boat formation. So you can draw cyclohexane just as a hexagon though. Cyclopentane, pent is 5 carbons. Cyclo tells us that it should have its ends closed. So the 5-sided shape is a pentagon. So you can draw it that way. Cyclobutane would just be a square. The alternative way of drawing it would be to draw the carbons and your hydrogens like so. Either way will be acceptable.